Video, we're going to talk about lesson 111, which is about conjunctions and disjunctions. We've learned about conjunctions before. So, for example, we've seen something like this. 4 is less than x is less than 14. And that means that x is between 4 and 14, but not including 4 and 14. So if we were to graph it, we would just draw a number line. We would have 4 and 14. And everything in between would be shaded, but they would have open circles around them because 4 and 14 are not part of the solution. So we can also complicate it a little bit more. We can even say something like 4 is less than x plus 3 is less than, 10. So you would actually have to solve both sides of this inequality. So you could think of it as two separate inequalities. 4 is less than x plus 3, and then x plus 3 is less than 10. If you solve this inequality, you would subtract 3 from both sides. So you would get 1 is less than x. And if you solve this inequality, you would subtract 3 from both sides, and you would get x is less than 7. So the simplified version of this inequality would be 1 is less than x is less than 7. In order to graph it, it would be basically the same we saw before, 1, 7. We would have open circles since those are not included in the solution, and everything in between would be shaded. We also have to pay attention to the domain. Sometimes the domain is real numbers, and this would be all real numbers because we're shading everything. But sometimes the domain is integers, and we have to be careful and take a look at the domain. So let's do an example. Example 1, we're asked to graph 5 is less than x minus 4 is less than 2. So the first thing we would do, we would solve both sides like we did before. And that would just mean we have to add 4 to each side. So I would add 4 here, and I would also add 4 here. So you can put it all together. You have negative 5 plus 4 is negative 1, is less than or equal to x is less than 6. The domain is integers, so we would just draw a number line, negative 1 to 6, 5, 4, 3, 2, 1, 0. And this first inequality sign is less than or equal to. So for this one, I'm going to go ahead and shade in negative 1 because it's a part of the solution, but 6 is going to have either an open circle or nothing. The reason it would have nothing is because my domain is integers. So all of these integers are going to get shaded in, but nothing in between. So 6 can be open, or it can be just ignore it and don't shade anything there. Whatever works best for you. Let's take a look at something a little bit different. A conjunction, we've seen conjunctions. Conjunction can use the word and. So if you look at this conjunction, we have x is greater than negative 2 and x is less than or equal to 4. So this can also be written negative 2 is less than x is less than or equal to 4. So it's kind of the same thing as using the word and, but we usually write it like this to show that x is between negative 2 and positive 4. But a disjunction, which is what we're going to focus on now, a disjunction uses the word or. So, for example, graph x is less than or equal to negative 2, or x is greater than 1. The domain is all real numbers. So this is actually pretty simple to graph. First, I graph the first one. As x is less than or equal to negative 2, so I put negative 2. I'm going to close the circle because it's included. And since it's less than, I'm going to shade over here to the left. And since it's real numbers, I don't have to do dots. I just shade it. Or x is greater than 1. So then I have 1 over here, and I can draw an open circle around it. and then I can shade to the right. My solution is all reals. So pretty simple. You just shade both inequalities. So some solutions are over here, other solutions are over here. Let's do example 3. Try this one on your own and then pause the video and we'll check back in just a moment. So checking the example 3 answer, we have two inequalities. X is greater than or equal to 3. So we would shade 3 and then we would shade to the right of 3. Only dots because the domain is integers. And then we have x is less than or equal to -2. So we're going to shade -2 and then everything to the left of -2. Let's look at one more example. Example 4. Go ahead and try this one on your own. Pay attention to the domain. All right, checking the answer for example 4, we have x is greater than 15 or x is less than or equal to +10. And the domain is real, so we don't have to do dots. We just shade the whole line. The open circle is around 15 and there's a closed circle around 10.